Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. I was discussing nomenclature. Now I will discuss isomerism. Isomerism in inorganic compounds. Particularly isomerism in coordination compounds, inorganic coordination compounds. But before going to that, I want to do some nomenclature that are important for your exam. Nomenclature of this few compounds are there. First, I will tell. Actually, a question is asked. Write the formula for the following coordination compounds. Now, actually, name they have given. You have to write the formula. Write the formulas for the given coordination compounds. Then I will tell the name of the compound, and then formula easily you can write. First compound I am telling you, tetraamine aqua chlorido cobalt third chloride. So you have to read the question very carefully only, then you can write the formula and you try to understand the meaning. Again I am telling you, tetraamine. Tetra, first you give value for importance for tetraamine. Amine means NH3. Tetraamine aqua chlorido. Aqua means water. Aqua chlorido means here related to chloride. Chlorido, and the end cobalt third, and the last, that is the counter ion, is chloride. Now you can write very easily. Formula you can write very easily. Then what will be the formula? Then formula, to write the formula, first you have to write, that is actually counter ion is chloride. It means chloride ion will be at the end. Then tetraamine means 4-amine. NH3 4, that is called tetraamine. Aqua means water. Aqua chlorido means here chloride is also in the complex. It comes under the complex ion, because see, counter ion is outside, that is the minus chloride. Then it means complex ion is positive. This is a cation, this carbocation, not carbocation, cation you can tell. Okay, means complex is cation, and that complex is of central metal ion is cobalt. It is given cobalt third, means it will have this thing, oxidation state of cobalt is 3 plus 3, correct? Then now you can write the formula. Cobalt third is there. Then first you write cobalt, and after that you have to follow the these things alphabetically you have to arrange. Then now cobalt you have written, then After that, ammonia you have to write amine, tetraamine. Then after the cobalt you write NH3 whole 4. And after that, aqua and chloro. Aqua and chloro, obviously that this aqua, before chloride, aqua will come. Okay. That also start with A only, aqua. Then H2O. It is nothing written, mono, di, nothing means mono only. Then H2O. And aqua chlorido. Then Cl you write, that's enough. Then now complex cation, now it is CO NH3 whole 4 H2O, and H2O is write in bracket. Okay, NH2 the H2O you write in bracket, and then Cl. Then now if you will write you will consider the charge of the ligands, then you can decide the these things, charge, complex on complex ion, how much charge is there, that because you counter ion you have to write. Then how many chlorine atom chloride ion you will write, how many. Then for that you have to consider the ligand's charge. Then now you can see cobalt third is there, that is clear, +3. Then 4 ammonia is there. It means ammonia is 0. Ammonia is neutral. Hence, for ammonia it is 0 charge. H2O, after that H2O is there. H2O is also 0. And third is chloride ion. Chloride. Inside the complex, chloride is there. And outside also, that is counter ion also, chloride is there. Then this chloride ion is there inside the complex, means in bracket, square bracket, chloride ion is there, only 1. Then 1 chloride means 1 minus. Then cobalt is 3 plus, and this 1 minus. Then now total charge will remain +2, +3 minus 1, +2. Hence outside or on complex, on cation complex, +2 you have to write, +2. Then now +2 is there. Then to neutralize, chloride ion will come, but how many? 2. That's why I should write Cl2. Cl2. That's enough. Now second question I am reading. Then I will tell the formula. Now potassium tetra hydroxo zincate second means oxidation state is 2. Then now by seeing the question, you should understand that potassium is only in the beginning, potassium, and after that potassium is beginning means that complex ion is anion, because potassium will be cation. Then complex is anion. Then now just read the question carefully, then you will understand. Potassium, that will be counter ion is potassium plus, K plus. But how many K plus? Now it depends upon charge on the complex anion, how many negatives are there. Accordingly you have to write the potassium. Then this potassium tetrahydroxo means OH. It is not aqua, it is hydroxo. Hydroxo means hydroxide. Then tetrahydroxo means 4OH, means OH4, OH4. And after that, tetrahydroxo means very easy, 4OH, cobalt, this zincate, not cobalt, zincate second, zincate. From that also you can understand that is the anion. Complex anion is there. The zincate second means Zn has oxidation state 2. Then now first just for the potassium you will write number of potassium, you will write later on. First you think complex ion first you write. Tetrahydroxo. Tetrahydroxo means OH4. Then after that zincate second means zinc you write, and it has 2 oxidation state, zinc 2 plus, and oxygen hydroxo means OH is 4OH means 4 negative, and 2 positive. Tetrahydroxo hydroxo means OH is 4. Then 4OH means 4 negative, and zinc is 2 positive. And finally on anion it will be 2 negative. Anion 2 negative will be there. Then you can write very easily ZnOH whole 4. ZnOH whole 4, that you will write inside the square bracket, and in that 2 minus is there. Then 2 for the 2 minus to neutralize. Now 2 potassium you will write, because each potassium is 1 plus. Then now in the beginning you write K2. You have to not write this charge on the anion, only you have to calculate, because finally K2 will write, it will neutralize. It should not appear. Because finally coordination compound you are writing, hence charge is neutralized. Need not required to write the charge. And now it became K2 as a cation, and anion is in a bracket, in a square bracket, ZnOH whole 4. That's enough. Now third question I am reading. Okay. Potassium tri oxalato, oxalic acid, oxalate ion, oxalato, and after that 3 parts are there. Trioxalato, 1, aluminate, only 2 are there. Trioxalato, and other is aluminate third, aluminate, ATE. It means obviously it will be anion. And by the question also understand potassium is only in the beginning. Then obviously potassium is a counter ion. Then trioxalato aluminate will be anion. How many charge? That you have to consider. You have to calculate. Then write first these things, complex anion. Then aluminate 3 is there. Means aluminum is 3 oxidation state. Aluminum has 3 oxidation state plus 3. Then now it is a trioxalato. Tri means 3. Oxalato means oxalate. 3 oxalate is there. Then each oxalate means 2 charge, 2 negative. 1 oxalate means 2 negative. Then 3 oxalate means 6 negative. Then 6 negative, and aluminum is plus 3. Then finally on anion it will be minus 3. Plus 3 on minus 6. Then it will be minus 3. That will be on the anion. 3 negative. Then 3 negative, to neutralize 3 negative, 3 potassium should come. 3 potassium, then it will come K3 as a counter ion, and in bracket, square bracket, AlC2O4 whole 3. C2O4 is oxalate. C2O4 is oxalate, 3 oxalate. Tri is given in question. Trioxalato. Then now compound will be K3, and inside the bracket means complex anion Al C2O4 whole 3. Need not required to write the charge, because finally you have written coordination compound. You write charge only when only cation you have to write, complex cation or complex anion. Only if you have to write, then only you charge you write. When you are writing compound, then counter ion is balancing it. Need not require the charge. Now next question I am telling you. Dichlorido bis ethane 1,2-diamine cobalt third. See, in this it is only complex ion you have to write. It is not the full compound. Not it the compound, only complex. Again I am reading the question. Question always you have to read and understand. Okay, very with careful. Then dichlorido. Dichlorido means 2 chloride. Dichlorido. After that it is a bis, bis, bis. Bis means again 2. Bis means again 2, bis, bis. Then bis for what? 2 for what? Which this 2 is for what? Which molecule? Which ligand you have to write. Then this is ethane 1,2-diamine. Ethane 1,2-diamine. Then this ethane 1,2-diamine, cobalt third. And cobalt third means cobalt is in third oxidation state. Then now for the ethane 1,2-diamine, what is the representation? How you are writing symbol? Then En. Ethane 1,2-diamine is written as En. En is the symbol. En means it is only for ethane. Ethane. Okay, ethane 1,2-diamine. It is represented as En. A small En. Then now how will you write the ion? Then now very easily you can write cobalt third is there. Then first write cobalt. Then it is a +3 oxidation state. Chlorine is 2 chlorine, means 2 negative. And ethane 1,2-diamine. Ethane 1,2-diamine. Okay. Then for this, how much? Then for this, that is also 2. This is also 2. Then here, chlorine 2 means 2 negative. Chlorine Cl2 means 2 negative. Then in is 1,2 this thing 1,2-diamine. Ethane 1,2-diamine, no charge. It has no charge. Ethane 1,2-diamine, because nitrogen is there. Nitrogen has only lone pair of electron. Hence, ethane also has no charge, diamine also has no charge. Then ethane 1,2-diamine means 0. Then ethane 1,2-diamine means En is bis, bis means 2. En whole 2. Then there is no charge for En. Then charge is only due to 2 chloride ion. Then 2 chloride ion means 2 negative and CO is 3 positive, and finally 1 positive will remain. on the complex ion. Hence, now it is complex ion became cobalt Cl2 En whole 2. And outside, actually En you should write in bracket, a small bracket. And finally, all things you write in a square bracket. Cobalt Cl2 En whole 2 must be written in a square bracket, and on the bracket outside you write 1 positive, 1 plus. Now next question I am reading. Tetracarbonyl nickel 0. Very easy to write. Tetracarbonyl nickel 0. Only ion is there, not the compound, only ion. Then nickel is 0. Nickel oxidation state is 0. Then now tetracarbonyl, tetra means 4, carbonyl means CO. Then very easy to write. NiCO whole 4. Carbonyl means CO, carbon monoxide. Then NiCO whole 4. CO is neutral. Carbonyl has no charge. Okay, 0. Hence, finally, a nickel oxidation state is also 0. Hence, usually you can write in a square bracket NiCO whole 4. CO you write in a small bracket. NiCO whole 4. This you have written in a square bracket. No charge, no negative, no positive. Okay. In this I have discussed, you can say, formula for the few given compounds, coordination compounds. Now I will tell you that now this formula is given. Formula is given. Now you have to write the name. So both type of question is asked. When formula is given, you write the name of the compound, coordination compound, name of the coordination compound. Now I told you for that when nomenclature this was given, when name was given, you were supposed to write the formula. Now formula is given, then you write the name. You have to do the nomenclature. Then first I am writing the, first I will read the name, then I will tell you how you write the compound, name of the compound. Then first I am reading the question, given question, that in a square bracket, it is written platinum Pt, NH3 whole 2, and then Cl, and then NO2. Three terms are there. 3 ligands are there. 3 type of ligands. Ammonia, first ligand, second is chloride, and third is NO2. And central metal ion is Pt, platinum. Then how will you write this? And this is no charge, nothing is written, no counter ion. No counter ion means here it means charge is neutralized. Platinum charge is neutralized, correct, by the ligand charge. That's why nothing is, no charge is written. Then now platinum charge and ligand charge must be neutralized. Then how will you write? Then now you can say platinum in ammonia is it is neutral. Ammonia is neutral, and chloride is 1 negative, NO2 is also 1 negative. Then means 2 negative is there, 2 negative. And this ammonia is neutral. Chloride is 1 negative, NO2 is 1 negative, and NH3 is 2, but it is 0, neutral. Hence total negative is only 2, 1 due to chloride, 1 due to NO2, then 2 negative. Then platinum actually have 4 oxidation state. Not platinum here, it has 2 oxidation state because no charge is written on the complex ion. No, nothing is written. It means it should be neutralized. Then here -2 is there, 1 due to chloride ion, 1 due to nitrate, and NO2, nitrogen dioxide. Okay, nitrite. Then 2 negative charge is there. It means platinum will be 2 positive. 2 positive. That's why it is neutralized. Nothing is showing. Hence, finally, you have to write platinate. You will write finally because it is no anion is not there. 0 is there. Then 0 and plus has same way you have to do nomenclature. Then platinum and the end will come and oxidation state will be 2. Platinum 2 you have to write. 2 you have to write in bracket. Then now you start with ligand. You start writing with ligand. Then now I told you this alphabetically you have to write the name of the ligand. Then ammonia, A letter will come. Chloride, C letter is coming, and nitrate third. It means you start with ammonia only. PTNH3 whole 2 is there. Then platinum we will write in the last. Platinum 2 you have to write in the last. Then ligand diamine. NH3 whole 2 you will write di for 2, di for NH3 amine. Diamine. After that you have to write chlorido for the directly chloride you can't write. Already I told you that chlorine is written as chlorido. D-O. The chloride is there, na chloride. That E you remove and O you write chloride. Then it become chlorido. And then nitrite is there. Nitrite ligand is there. Then for that you will write, after when you have written chlorido, then now write nitrito. Here also this NO2 is there. Then and the end you write O. Then nitrito. Correct? Because it is not the nitrate. Nitrite was there. That for nitrite it is written nitrito. Then now your complex is complete because this all you have written diamine, chlorido, nitrito, N platinum second. Why you are writing the word N? Because here platinum is joined with N, NO2 is there, it is joined with that. Okay, that's why N platinum second, because platinum is joined with N. Then N platinum second. Now like that way other question I am reading. K3CR. K3 counter ion is outside. K3 in bracket Cr C2O4 whole 3. It is very easy to write K3. Then first you have to write the potassium written, and after that chromium you will write this second, that is the chromium is there, that because it is an anion, and chromium you can't write. You will write chromate you have to write ATE, chromate. Okay, not chromium, you can write only in cation, but it is anion. Then chromate you will write. And what is actually charge? Charge you have to write, oxidation state you have to write for chromium. Then you have to calculate, but you can understand. But better you calculate than you can write, because see, K3 is there. K3 means anion is K3. K3 plus, 3 plus is there, it means anion, this complex anion is minus 3. K3 means 3 positive. Then anion have, complex anion have 3 negative. Then now 3 negative is there. Then what is the oxidation state of chromium? Then C2O4 whole 3 is there. Then 1 C2O4 means minus 2. Then 3 means 3 C2O4 whole 3. Then 6 minus 6. But in complex minus 3 is there. It means chromium is plus 3. Plus 3 minus 6. Only then you can write minus 3. It means chromium is plus 3. Then here you write chromate third. Then very easily you can write can do the nomenclature. Potassium, and then you write tri, because C2O4 whole 3 is there. Then trioxalato chromate third. Trioxalato chromate third. Now next I am telling you, next this formula is given. Cobalt Cl2 En whole 2. This is inside the bracket, and counter ion is Cl, only one Cl. Then obviously if one Cl is there, then anion is 1 positive. Complex anion is 1 positive. Then now, because you have to find out the cobalt oxidation state, then you have to consider the complex ion. Then complex ion is 1 positive. Now see, inside the square bracket 2 chlorine is there, and En whole 2 is there. En means you know ethane 1 to diamine, don't forget. In means ethane 1 to diamine. No charge is there, no charge. Then now how will you write that? I will do the nomenclature. Then you start with cobalt. What will you that this oxidation state of cobalt? First you calculate. Then cobalt Cl2 En whole 2. Then En is 0. Then no problem. Then only Cl2 is there, means 2 negative, and outside 1 positive is there. 1 positive is there outside, and chloride is 2 chlorine is there, means 2 negative. It means cobalt was having 3 positive. Then 2 negative neutralized. Then finally 1 positive is on complex ion, on cation, complex cation. 1 positive, because when cobalt was 3, having 3 only, then 2 negative gone, 2 negative, then only 1 positive was remaining. Then cobalt is third. Then now all thing is clear. Then now first you write cation, and then you write counter ion. Then alphabetically you have to follow alphabetically. Then En means is starting with E, and chloride is starting with C. Hence you should start writing dichlorido. Okay, dichlorido, don't forget, and the end O you have to write dichlorido, and after that dichloride is over. Now ethane 1 to diamine, ethane 1 to diamine, for that whole 2 is there. Then bis you have to write BIS. Then you can write dichlorido bis, and in bracket you write ethane 1 to diamine. And after that complex ion is going to be completed with central metal ion. Then what you will write? Cobalt third. Cobalt third. Okay. Main things is written in the complex cation. Main thing is written in the end. In anion also. But there ATE you are writing. But here not like this. Direct name. Name of the metal. Then cobalt third. Third you can write in bracket Roman. In a Roman way, Roman numeral you can write. Then now you have written dichlorido bis, in bracket you write ethane 1 to diamine. After that cobalt third, and counter ion is chloride, then write chloride. Okay, one chloride is there, chloride you write. Now next I am telling you that also you can write very easily. That is the cobalt NH3 whole 5. Cobalt NH3 whole 5. After that carbonate is there, CO3. CO3 in a square bracket means as a cation, complex cation I am talking about cobalt, and after that NH3 whole 5, and then CO3. Always ligand you write in a bracket except chloride. Then cobalt NH3 whole 5, CO3 also it is in written bracket only, and now counter ion is Cl, means 1 negative. Then 1 negative means complex cation is 1 positive. 1 positive. Then what is the oxidation state of cobalt? Then now easily you can write NH3. NH3 is a neutral, no charge, 0. Then no problem. Carbonate is a 2 negative, CO3, Na2CO3. Then CO3 is 2 minus, sulfate is 2 minus, all the things. Then here NO3 is 2 negative. And finally on the complex it is a 1 positive. You have seen because counter ion is 1 and negative, Cl. 1 minus. Then obviously 1 minus is telling that complex ion is 1 positive. And here cobalt you have to find out oxidation state. Then NH3 5 is there, but it is a 0. Carbonate is 2 negative, minus 2. It means cobalt was plus 3. Cobalt was plus 3. Correct? Very easy way you have calculated. Plus 3. Then now we start writing with complex ion. Then again ammonia, A letter. Carbonate, C letter it is coming. First ammonia write. Then what you will write? Pentaamine. Pentaamine carbonate is there. Pentaamine carbonato. Pentaamine carbonato. O you have to write always. Pentaamine carbonato. And after that very easy, cobalt third. Cobalt third, because it is a cation, you have to not write ATE. Cobalt direct name, cobalt third. And counter ion is chloride. Then you write chloride. 1 Cl is there, chloride. One more I am telling you. That is the Hg. Hg, it is just like a counter ion, Hg. And in bracket, square bracket, cobalt SCN whole 4 is there. SCN, thiocyanate, HCN 4 is there, whole 4. Then Hg outside mercury is as a this things counter ion. Then now you have to write the you have to do this things nomenclature. Then for Hg generally it will plus 2 sometimes plus 1 also. But now you have to calculate the you can say charge of cobalt. Then thiocyanate SCN is minus 1. Then 4 minus SCN whole 4 is there. Then 4 minus is there, and cobalt is third. Cobalt is automatically because outside Hg is there, and SCN is a 4 thiocyanate means 4 negative. Then 4 negative is there. Then cobalt is of third. Third. Then it will be what? Minus 1. Complex ion will have minus 1. Then Hg will be plus 1. Cobalt is of third, oxidation state third, and 4 minus is there. Then minus will be there, anion will be 1 minus. Then Hg will be only Hg plus, not Hg plus plus. Then very easily you can write the these things nomenclature. You can do very easily. Hg means mercury. Mercury you write first. In cation, in complex cation, if complete compound is there, then first you have to write the cation, then anion, just like in general way, sodium chloride, potassium chloride, like that way. Okay, because it is given complete compound. Then Hg, for Hg we write mercury, and then SCN4 is there. Now we have started writing complex anion. Then tetrathiocyanato, and cobalt, because it is anion, you write ATE and the end. Then cobaltate, and it is third oxidation state, write third. Then in this way easily you can write the you can say formula, as well as you can do the nomenclature. Okay, in examination this question is asked. In all examination, medical, engineering, even for general also sometimes general competition also they are asking. Then I told you method how to do nomenclature with example. Now actually you should do practice. Many questions you will find. You just you do more and more practice is required here. You take any question and you try. Okay, both. Formula is given, then do nomenclature. If a name is given, to write the formula. Both type of question is asked. Now I am going to start isomerism in coordination compound. Isomerism in coordination compound. It is also very, very important. Isomerism in coordination compounds. Isomers are two or more compounds that have the same chemical formula but a different arrangement of atoms. What is the isomers? Listen carefully. Isomers are two or more compounds that have the same chemical formula but different arrangement of atoms. Because of the different arrangement of atoms, they differ in one or more physical or chemical properties. Two principal types of isomerisms are known among coordination compounds. Two principal types of isomerisms are known among coordination compounds, and each of which can be further divided. Then what are the principal principal types of isomers? Isomerism, two types. First main, then first is stereoisomerism and second is structural isomerism. These are the major two types. Major two types of isomerism. First is stereoisomerism and second is structural isomerism. Now stereoisomerism is of two types. Stereoisomerism is of two types: geometrical isomerism and optical isomerism. Remember always, stereoisomerism is of two types: geometrical isomerism and second is optical isomerism. Optical means related to light. Okay, related to light. These molecules has effect, will be affected by light. Optical means light. Optics means light. You know all the things. Then second, I told you, first is geometrical isomerism and second is optical isomerism. Now second main type, that is the structural isomerism. Structural isomerism. These are four types. Structural isomerism is of four types. First, linkage isomerism. Linkage isomerism. Second, coordination isomerism. Third, ionization isomerism. Ionization isomerism. And fourth, solvate isomerism. Solvate isomerism. Then structural isomerism is of four types. Linkage isomerism. Second, coordination isomerism. Third, ionization isomerism. Fourth, solvate isomerism. Now come to the stereoisomerism. Stereoisomers have the same chemical formula. And chemical bonds both are same. Okay, stereoisomers have the same chemical formula and chemical bonds are also same. Then where they are differing? But they have different spatial arrangement in a space. Bonds are also same chemical bonds, same chemical formula, but they have different spatial arrangement in a space. Okay, this is the main things of stereoisomers. This structural isomers. What about the structural isomers? Stereoisomers, I told you that stereoisomers have the same chemical formula and chemical bonds, but they have different spatial arrangement. Then what about the structural isomerism? Then structural isomerism have different bonds. Bond will be different. Okay, this you understand. Stereoisomers, I told you, they have same chemical formula and chemical bond. But in structural isomers, they have different bonds. Okay, this is the difference. Now come to the geometrical isomerism. What is this? Already I told you, geometrical stereoisomerism is two types: geometrical isomerism and optical isomerism. Then come to the geometrical isomerism. Then it is very easy to understand. Okay, this type of isomerism arises in heteroleptic complexes. Due to different possible geometrical arrangement of the ligands. Different possible geometrical arrangement of ligands, keep in mind in a simple way. geometrical arrangement of ligands in a space. All things will be the bond will be the same. Formula will be the same. Ligand arrangement will be different in a space, a spatial arrangement. And this type of isomerism arises in heteroleptic complexes due to different possible geometrical arrangement of the ligands. Okay. Generally, actually, these things it exists in the coordination numbers 4 and 6. Coordination number will be generally 4 and 6. Important examples of this behavior are found with coordination number 4 and 6. In that, 1 will be in 4 and 6 means 4 means it will show in a square planar complex of formula mx2 L2 mx2 L2. X and L are unidented. X may be halogen, then X and L may be other ligand, but both are X and L are unidented. Total 4 ligand, X2 and L2. X also as a ligand, L also as a ligand, and total 4. M is central metal ion. Then mx2L2. This will show the square planar complex, and its formula will be mx2L2. The two ligands X may be arranged. Now understand arrangement. The two ligands X may be arranged adjacent to each other, means nearby to each other. Then when they are just near to each other, then this is called cis isomer. And if they are opposite to each other, opposite means far to each other, opposite to each other, then it is called trans isomer. Then here one example I am telling you, that platinum complex I am telling you. PT is in the middle. It is just like a square, four corners of a square. Then platinum is in the middle. 4 bond is there. Then 2Cl is just like in a square nearby. Both are close. One side of a square nearby. Cl. And ammonia, 2 ammonia is there. Both ammonias are again together, close, adjacent to each other, close to each other. And all 4 bonds are joined with platinum. It is looking like if all points will join, then it will become a square. Then platinum in the middle, 2Cl. 2Cl is nearby, adjacent, that is called adjacent. And 2NH3 is again nearby, close. Okay, that is called NH3. Then here when both Cls are here nearby, means adjacent, and both NH3 is again nearby. Then this is called cis, CIS, cis. Here both Cl are close and both NH3 are close. Now second case you consider, platinum is in the middle as it is, but now NH3 is opposite, very far distance, opposite. One is one end, other is first end, other opposite. Okay, means two side you can tell, farthest you can tell. Like same way, Cl is again far, opposite. Then this is called trans. When NH3 is far and Cl is also far, opposite. Then but it again it will join all points. It will look like a square. Then it is called just like when they are close, adjacent, it is called cis. When they are far, or you can tell opposite arrangement is there, then it is called trans. Okay, then this is actually geometrical isomer, cis and trans of PT, and PT you can write outside, and in a square bracket you can write NH3 whole 2 Cl2, NH3 whole 2 Cl2. Okay, then this I have told about the geometrical isomerism. One more I will tell you. Here actually cis and trans, it is a square planet because only 4 are there, and platinum is in the middle, central metal ion is in the middle. 4 ligands are taking a form of a square. That is a 4 oxidation state. Or you can tell coordinate number 4. 4 bonds are there. 4 bonds means coordination number is 4. 4 coordination number. Like that way, 6, I want to tell you example of 6 coordination number. Then here I am taking example of cobalt NH3 whole 4 Cl2. This is the cation. Outside 1 plus is there. Cobalt NH3 whole 4 Cl2. Then total 6, NH3 whole 4 and Cl2, 2. 4 plus 2, 6. These are attached with cobalt. Cobalt is in the middle. Then now 4 NH3, all 4 NH3 you can write adjacent. It will look like it is a surrounding. Just like if you will join, it will look like a circle. Okay. Then 4 points are close. NH3, 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 NH3. All 4. You can join with single bond. And 2 more chloride is there. Again both are close, means adjacent. All NH3 are adjacent. All 4 NH3 are adjacent. And these 2 chlorides are also adjacent, means close. Then this is the example of cis. All are adjacent. That's why it is cis. All ammonia are close and both chlorides are close, means adjacent. All are ammonias are adjacent and chlorides are also adjacent. This is the example of cis. And coordination number 6 bonds are there. Then 6 coordination number. Now come to this trans. Now only in this arrangement you are making change. If you will make same arrangement, means it will be just like a circle only. If you make it, it will look like a circle. And outside 1 plus is there. In a complex, that outside 1 plus is there. Now trans here what will happen? Same compound, same this structure I am telling you. Now Cl you can write opposite. Cl you can write opposite. Then what will happen? It is a trans. Both Cl are not adjacent. Now they are farthest Cl. And you can also understand Cl both side opposite are there. It become far. Then now left side 2 NH3 and right side 2 NH3. Then here again you can see both NH3 are far. Both are adjacent. NH3 left side. Both are close. But other 2 are again far. All 4 are not close. All 4s are not close. 2 are this side, left side, 2 are right side. Then all 4 means 2 left side, 2 right side, they become far. And Cl is only 2 Cl was there. Both are also far. That it is an example of trans. Okay. Then this I told you these things. Example I told you about the CO NH3 whole 4 Cl2 of 6 oxidation state. Then other square plane example of the type you can write MABXL, means for a square also all ligand may be different. Maybe one may be A, other may be B, third may be X, fourth may be L. All are there. Where A, B, X, L are unidented. Unidented shows 3 isomers. But if you will try to write, then you can write in 3 ways. This M is the metal, central metal ion, and ABXL are unidentate ligand. But you can write this isomer in three types. Three isomers. If you write, you can write in three ways. Three isomers. Two will be of cis type, one will be of trans type. Three isomers you will write. You can write in three ways. MABXL. You can arrange, then you will find you can write only three ways. After that, repetition will start. Okay. Then these three isomers are there. In that you will find two are cis and one is trans. Now for this other plus 6, already told you oxidation number 6. And one important thing I am telling you, such isomerism is not possible for a tetrahedral. Only it is possible for a square planar. Question is asked. What I told you, MABXL, it is possible only for a square planar, because all are in a plane. You can arrange in a plane only, then a square will be formed. In tetrahedral, there is no question of a square. Hence, such type of isomerism is not possible for a tetrahedral geometry. But similar behavior is possible in octahedral complexes, means 6 octahedral complexes. It is possible. And you can write in a general way, octahedral, you can write MX2L4. X may be halogen and L is the any ligand, 4 ligand. Then octahedral can be written as M is central metal ion, MX2L4, in which the two ligands X may be oriented as a cis. Generally, halide will be oriented as a cis, means far. Cis means adjacent. In MX2L4, that X may be, only two are there, then X may be oriented as cis. Sometimes as a cis or sometimes as a trans. Okay, trans to each other or cis to each other, means nearby, adjacent. Okay. Then now this one more example I want to tell you. That is for 6 I am talking about. Condition number 6 means 6 bond it will make. Then ligands may be EN, ethan 1 to diamine, EN. Then it has two linkage, it can donate, two atom can donate, two negative charges there, that you know. Then if 2 EN is there, means 4 negative, 4 negative, and 2 may be others, halogens, like Cl. Then now you can arrange in a two ways. When both you can say Cl are, suppose in the middle cobalt is there. I am telling example of cobalt Cl2 En whole 2. Cobalt Cl2 En whole 2. Then here both central cobalt may be in the center, both chloride may be adjacent, and both En may be adjacent. Then this is the example of cis, because both Cl are adjacent, close, and both En are close. But each En is making 2 bond. Then total 4 bond, and 2 is due to 2 Cl, total 6. Then when both are adjacent, En is adjacent, Cl is adjacent. Then it is the example of cis cobalt Cl2 En2. And when both Cl are opposite, cobalt is in the middle, and both Cl are opposite, means far. En is also opposite. Both En are opposite far. Then this is the example of trans. Okay. Then this I have told you about the I can say geometrical isomers of 4 oxidation number 4 and 6. Okay. Next class I will continue isomerism. Thank you.